In this lecture, we're going to learn all about 2D and 3D in Unity. In order to make a 2D or 3D game, all you need to do is really just use different components. So for example, if you're working on a 2D game, you will primarily be using the sprite render component. So let me make a completely empty game object. And here by default it has the transform component, and then we can add a sprite render component. This one has a field for a sprite. Now here on the project files I've got this texture. As you can see up here on the texture import settings, you can see the texture type, and this one is set up as a sprite. On the texture itself over here on the project files, it also has this tiny arrow, and if you click on it, you expand and you can see the underlying sprite. So if you set the texture import settings as texture type of sprite, it automatically creates a sprite from this texture. And then on the sprite render itself, you can simply drag it and it automatically assigns a sprite. So there it is, there's my sprite. Now with regards to 3D, instead of having a sprite render, let's create another game object, just push it to the side. So in 3D, instead of a sprite render, what you have is a mesh filter component. This one has a field for the actual mesh you want to display. So for example, let's choose the included cube. And just like this, it doesn't see anything, so there's no actual visual. So in order to set the visual, you need to add the mesh renderer component. So this is the component that actually renders the mesh. So just like this, we can already see our cube mesh. Now we see it in pink because in 3D it requires a material. So on your project files, you can simply go into create a new material, then select the object, assign the material, and there you go. For the material, I'm using the standard universal render pipeline lit shader, and this one has a field for the base map or the main texture. But again, this one is a texture, it's not a sprite. Those are two different things. So for example, I've got a texture right here. As you can see on the texture import settings, the texture type is set up as default, so this one handles pretty much every format. So I'm using default instead of sprite, and now I can assign this texture, and there you go, now my cube has a texture. So here you have a 2D sprite and a 3D object. Now the main difference is the change between a sprite renderer onto a mesh filter and a mesh render. Also in 2D, you import textures and you set the texture type as a sprite, whereas in 3D, you use the standard default texture type. If you attempt to drag a normal texture over here onto the sprite field, you'll see that it does not work. But since sprites are also textures, you can drag the sprite texture, yep, there you go, in there. So all of these act as textures, but only this one acts as a sprite. Now another quick note, which is over here on the sprite renderer, you also have a field for the material. So this can be useful in case you want to render your sprite with a different shader or a different anything. So in essence, Unity is a 3D game engine. So what this sprite render object is really doing, it's really the exact same as having a normal object with a mesh filter and mesh render, except for the mesh, you set it up as a quad. So let's duplicate, put it to the side. And in here, instead of a cube, let's choose the built-in quad mesh. And now for the material, let me make a material, call it the same thing, and assign this texture. And now just assign this material, and just need to make sure that this one is transparent. And there you go. So here I'm using a mesh filter and a mesh render with a quad mesh, and then here I'm using a sprite render. So functionally, these two are pretty much exactly the same. So the sprite render is just Unity making it easy for you to create 2D objects, but again, always keep in mind how in the end everything exists in a 3D world. Then when it comes to scale, for the 3D object, the scale depends on the value over here on the scale, as well as the scale on the mesh itself. So the default cube is 1 by 1 by 1, so if you set it 1 by 1 by 1, then everything matches up perfectly, and if you want to scale it up, you simply just modify these values. However, in 2D, when working with a sprite render, you can also obviously modify the scale here, yes you can do that, but the basic size for the actual sprite object, so if you set the scale 1, 1, 1, how much size does this occupy? That is going to depend on the settings over here on the texture. So on the texture, if you have texture type as sprite, then here you see a field for the pixels per unit. So this is how many pixels equals 1 unit in the world. So over here I have it set to 300, which just happens to be the exact same size as this texture. So this is 300 by 300, and I've got the pixels per unit at 300. So that means that 300 pixels equals 1 unit. So by setting it like this, then this unit is essentially 1 by 1. So it has 1 width and 1 height, and since it's a sprite, it doesn't have any depth. However, if I choose my texture, and in here for the pixels per unit, let's say that I put half of this. So let's say that I put just at 150, and I hit on apply. And now there you go, now the sprite is essentially double the size. So the scale is still the same, 1, 1, 1, but the sprite is now occupying 2 units on the X and 2 units on the Y. So when working with sprites, it is very important to be familiar with how the pixels per unit setting works. Like I said, you can also modify the scale over here and it will actually scale the object. But if you're making a 2D game, then you should primarily play around with this value instead of modifying the transform scale on every object. Then a bit more of these 2D settings. For example, over here, the mesh type, you've got tight and full rect. So what this means is the underlying mesh shape. So if you go up here onto shaded, we can change the actual drawing mode. So if you go into shaded wireframe, then we can see the actual mesh. So when I said a while ago that the sprite render essentially makes a quad, that's not entirely true. If you set it as tight, then it will try to cut exactly the accurate shape matched up to the sprite. This is done to prevent overdrawing, which is usually a big issue when it comes to drawing performance. So if you set it as tight, Unity will try to make the mesh that kind of matches the visible area of the sprite. And if you instead change it to full rect, then now, yep, you do get an exact quad, exactly the same as a normal quad. So if you are limited by number of vertices, then you should use full rect. However, in most cases, using tight will actually be helpful, because even though you have more vertices, you will have less overdraw, which usually helps on performance. And then another one is over here, the pivot. So if I select the object and up here I make sure that I'm looking at the pivot. If I do that, then you can see that the pivot is right down the middle. And if you change from pivot from center, let's say to the bottom, so the bottom center, and you hit on apply, then now, yep, that is the origin of the game object. So it's on 0, 0, 0. So that is the origin, and the sprite is above it since the pivot is down on the bottom. So this will then affect how you scale it. So for example, now with that one on the bottom, if I modify the Y, it only modifies the height, only goes up, as opposed to if I have it right down the center and I modify it, now it expands from both sides. So for example, if you've got a texture for a health bar, it might be wise to put it, for example, a pivot on the left so you can then easily modify the scale. And then if you're working in 2D, another thing you also have are 2D specific lights, which have a whole bunch of 2D specific features. What you need to do in order to use them is make sure that you're using the 2D renderer. So over here, I'm using the universal render pipeline. And then I also have created a 2D renderer. Now go watch the lecture on render pipelines if you don't know about URP or the 2D render, but essentially you just right click, go into create, go into rendering, URP, you create a pipeline asset and then a 2D render. Now the pipeline asset, I have both of them, so I've got the standard render, so this is a 3D render, and then I've got the 2D specific render. Now if you set it as default, it will now activate this one, and with that one active, now if you create a new sprite renderer, if you do and you're using the 2D render, note how this one by default will have the material spritelit default, whereas the one that I created previously, it assigned the default material sprites default. So this one is unlit, and this one is lit, and lit specifically by 2D lights. So for example, on this one, if I now assign it, we can see that it's in full black. That is because there are no 2D lights on the scene. So let me just hide the other one. Another quick 2D tip. Up here on the top left corner, you've got this button to toggle between 2D and 3D view. So if you click on it, then essentially it just flattens out the scene view so you can easily see it in 2D. So here I've got my 2D object using the spritelit default, and there are no 2D lights, so that's why it's in full black. So for the lights, you simply right click on the hierarchy, go into create, let's create a new light, go into 2D, and let's make a new global light 2D. And as soon as you do, the sprite is now lit. This is a global light, so it affects the entire world. It affects with this color, this intensity, with this blend style, and so on. And for the blend styles, they are on the 2D renderer, so here you've got a whole bunch of 2D specific features. So if you're working on a 2D game, chances are you want to use the 2D renderer, which lets you use these lights. Then if you're working in 3D, again, just make sure you're using the 3D renderer. And then you go into create a new light, then let's say a point light. And now here you have a 3D light. So the cube is affected by this 3D light, but this other object using the spritelit default, that one is not affected by this 3D light, it is only affected by 2D lights. But then this other one that I made as a quad, using the standard URP lit, standard material, this one is affected by 3D lights. And the other big difference is simply the camera. So over here I've got my main camera object. If I'm working on a 3D game, then over here on the projection, I want to set it to perspective, which gives you a certain field of view. Now what this means is that objects closer to the camera appear bigger, and further away they appear smaller. And if you go to the edges, they appear more and more distorted. However, if you're working on a 2D game, then instead you want to set the projection to orthographic. And the size over here is the vertical size. So with the size of 5, that means that I'm seeing 5 units from here to here and 5 units from here to here. So the total height of the visible area is 10 units. So down the middle, I've got 0.00, up here 0.05, down here 0 minus 5. And with an orthographic camera, what that means is there's no field of view and no depth. So even as I grab my cube, which is still a 3D object, and I move it left and right, there's no distortion. I move it backwards and forwards, and there's no change in size. But again, as I mentioned before, Unity is still a 3D engine. So even if I've got my sprite object, in 2D you would only move left, right, and up and down. But again, it's a 3D engine, so you can still move it on the Z, even though in 2D it doesn't make a difference. Usually, when working on a 2D game, you want to make sure that you keep the Z of the objects always at 0 and only modify left, right, and up, down. So those are the main differences, but of course you can always mix and match as much as you want. For example, one approach which creates an interesting look is to have flat 2D characters in a 3D world. I've used this approach in a bunch of minigames that I've made. It creates a very interesting look. Another approach you can take is to make your game in full 3D but use an orthographic camera instead. This can also make for an interesting look. So go ahead, make any game you want, do it in 2D, 3D, or mix and match.